combined gas law. So what we've talked about so far was we had 3 different variables. We had pressure, we had temperature, we had volume. And with our 3 different variables that we had, individually we looked at each of the different gas laws and we held one variable constant. So when we held one variable constant, maybe we held temperature constant in Boyle's law, or maybe we held pressure constant in Charles' law. But what actually happens more in the real world is the fact that all of the variables are very intertwined with one another. As you saw in the demonstrations that we did in class, or in the videos if you watched the demonstration videos, it's very difficult to figure out what variable is being held constant because you can kind of argue pressure versus volume because they're so connected to one another. It's very easy to hold temperature constant, but the other two are pretty dependent on one another. So what actually happened was we took the different variables that we had in your 3 different gas laws and they put them together into one equation. If you notice, pressure and volume are always on the top of the equations. Like in this equation, it's over 1, so P and V are on the top. Temperature is always on the bottom. So what we can actually do is we can take all 3 of those gas laws, Charles, Boyle, and Gay-Lussac, and put them together into one combined gas law. They just called it the gas law. They didn't call it anything special or anything like that. They just took the 3 gas laws that we had, combined them together. So when we have the pressure, the temperature, and the volume, none of those variables are going to be held constant. They are all going to change. Pressure is going to change, temperature is going to change, volume is going to change. The only thing that's really being held constant is the number of particles that are present in the equation. So your mass stays the same, your moles stay the same, the number of molecules stay the same, whatever you're looking at there, but your pressure, your temperature, and your volume are all going to change. So we get a new equation on this one. It is P1 times V1 over T1. So your initial pressure, temperature, and volume is equal to your new or final pressure times volume over temperature. So P1 times V1 over T1 is equal to P2 times V2 over T2. On these math problems, you're going to get 5 variables and you have to solve for the 6th one. So people get kind of intimidated when you see the numbers because there's so many numbers, but if you kind of piece it together little by little, you'll be able to figure out which variable is which, just like we did with the other gas law people. So I'm going to switch over to my document camera, and we're going to do the math here. These example problems are the same ones that are in your notes, but we have P1 times V1 over T1 is equal to P2 times V2 over T2. The question says a sample of air in a syringe exerts a pressure of 1.02 atm at 22 degrees Celsius. The syringe is placed into boiling water, which is 100 degrees Celsius. The pressure is increased to 1.23 atm by pushing in the plunger, which reduces the volume to 0.224. What was the original volume? So right there, it tells me right off the bat, I'm solving for V1. Everything else we're going to have to kind of figure out. So it says that I have a syringe that's at 1.02 atm. So that is my first pressure. And then it says that my pressure is going up to 1.23. So there's P2. My temperature starts at 22 degrees Celsius and it goes up to 100. So there's my 1 and my 2. Now I already know that I'm solving for V1. So it says that after I change the pressure by pushing in the plunger, it reduces the volume. So this one is my V2. So taking a little bit of time to figure out what all of your variables are, like I said, is usually the most difficult part about this. After you have that, you just have to make sure that you have ATM, you have Kelvin, and you have liters. Once you have the correct units, then you just plug it in and do the math, just like in algebra class. So 1.02 ATM is a good unit, but the 22 degrees Celsius is not. I need to change that to Kelvin. So 22 plus 273 gives me 295 Kelvin. The 100 plus 273 is 373 Kelvin. Don't need a calculator for that one. And this one is milliliters. That has to go to liters. So I'm going to divide by 1,000. 1, 2, 3 times. I'm going to move my decimal place. So you get 0.000224 liters when you do that conversion. So once I have everything there, then I'm going to plug in my answers to my equation. I have P1 times V1. Oh, that's what I'm solving for. Over T1 is equal to P2 times V2 over T2. Now, once you have all of that, we're going to go back like we did last with the last problem set, and we're going to cross multiply. 1.02 times V1 times 373 is equal to 295 times 1.23 times 0.000224. I need to get V1 all by itself. To get V1 all by itself, I'm going to divide both sides by 1.02. I'm going to divide both sides by 373. So now I just need to get my calculator and do that math. When I do that math, you're going to take 295 times 1.23 times 0.000224 divided by, here I'm multiplying two numbers and they're both on the bottom of that problem, so I'm going to open parentheses. 1.02 times 373, and I'm going to close up those parentheses. So when I do that, I don't have to do a separate math problem here. I can just hit enter. This number has 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. Hey, guess what? We're going to have 3 sig figs. So you get 2.14 times 10 to the negative 4th liters. Or if you're using a different type of calculator, it might write it out using non-scientific notation. I don't have a preference with how you write that, but it might tell you 0.000214 liters. Those two numbers are identical, so it's up to you how you want to write that answer, if you want to use scientific notation or not. Now, just as a hint to you as well, some people like to rearrange the problem first before plugging in all the numbers like this. I don't care what method you use. That one is totally up to you. In the second example problem, I'll show you how to do that by rearranging the problem first. So this one says a gas cylinder is at 0 degrees Celsius. It has a pressure of 1.00 atm and contains 30 milliliters. The temperature increases to 30 degrees Celsius. The pressure increases to 1.20 atm. What is the new volume? So I'm solving for V2. So if you wanted to, again, sometimes people find this easier, some people don't. I don't really care either way. So P1 times V1 over T1 is equal to P2 V2 over T2. I switched those letters, but that's okay. It doesn't really matter. I'm going to cross multiply. P1 V1 T2 is equal to T1 V2 P2. I'm solving for V2, so to get that variable all by itself, I kind of ran out of room, sorry. T1 I'm moving over, P2 I'm moving over. So when I rearranged my variables, I'm going to plug these in as P1 times V1 times T2 over T1 times P2, and that's equal to V2. So I took my original equation and I just rearranged the variables here instead of rearranging it with the numbers. You get the same thing either way. It's up to you. Celsius needs to go to Kelvin, so there's my 373 Kelvin. When I add 273 to 30, I get 303 Kelvin. Milliliters need to go to liters. 1, 2, 3 times I'm going to move my decimal. And ATM and ATM, I'm good there. So now I'm just going to use my rearranged math problem here to plug in my answers. Nope, I don't know what my variables are. It says a gas cylinder is at 0 degrees Celsius, has a pressure of 1 atm, and contains 30 milliliters. So this is my volume 1, pressure 1, temperature 1. My temperature increases, so my new temperature is there. the pressure increases, so there's my new pressure there. So P1 is 1 atm times V1, 0.0300 to keep those sig figs, times T2, which is 303, over T1, which is 273, and then P2 is 1.20. So once you have all the correct variables, this is another way of writing it. I try not to write it with the parentheses because people then try to use that method when you're using your calculator. But when you plug this into your calculator, if you write it like this, you're going to take 1 times 0.03 times 303, hit equals, divided by, open parentheses, 273 times 1.20 and hit equals again. So I'm going to take 1.00 times 0.03 times 303 divided by, open parentheses, 273 times, I just lost my light. There we go. Sorry. 273 times 1.20. So you see how I use parentheses again on the bottom because you have two variables. I need 3 sig figs in my answer because it's 3, 3, 3, 3, and 3. So 3 sig figs, I get 0.0277. I am solving for volume. Volume is always in liters. So I hope that that helps when you are getting your answers. Like I said, you can rearrange the variables before or after. It doesn't matter. You can plug it into the numbers, whatever method works for you the best. If you guys have questions, ask. Otherwise, I hope you have a great day.